Now let's discuss on integration using trigonometric identities. Now here what we are going to discuss is how to find the integrals of a given function using trigonometric identities, which we have studied in class 11. I hope you remember it. If not, I am just putting a short note. I'll prepare a note and I'll put the trigonometric identities in the alash. Okay, so you can have a look on it also. Fine. So trigonometric identities and the formulas that we are using now for integration, this will be put in alash as a note. In note session I'll put it. Okay. So you can get it through alash. Then now coming to this, if not in alash, then I will put it in the Google Classroom also. So whichever way that I can, I will be putting it. Okay. So using trigonometric identities. So which are the trigonometric identities that we are going to use here? So cos squared x I have written in terms of cos 2x. Sine squared x I have written in terms of sine 3x. So all those things. Cos squared x as how do you write cos squared x? You will write cos squared x as 1 plus cos 2x by 2. Sine squared x, how will you write? 1 minus cos 2x by 2. So these are the major ones that I am going to use. Then definitely we have the other formulas also. So when it comes into the problem session, I will be discussing on the problems also. Just a recalling of the formulas. Okay. So right away we are moving on to the problems. Okay. So the first problem here I would like to discuss is integral of sine square 2x plus 5. Okay, so I am going to discuss is what integral of sine square 2x plus 5. Now here I know that what is sine square x. Now here in sine squared x I will not be able to write or integrate it directly. So I know that sine squared x is equal to 1 minus cos 2x by 2. Isn't it or not? So this is the formula that I am going to apply here. So I get this as integral of 1 minus cos 2 into, in terms of x, what do I have? 2x plus 5 by 2 into dx. Now 1 by 2 is a constant, let it remain outside. Integral of 1 minus cos 4x plus 10, right, into dx. So what is the value? 1 by 2 into integral of 1 is x minus integral of cos x is what? Integral of cos x is actually what? Substitution method. I can write this as cos u, or simply integral of cos x is sine x. So I'll write it as sine of 4x plus 10 by 4 plus, see, how did I get this 4 here? If you see, if you put u is equal to 4x plus 10, then du is equal to what? 4 into dx. So du by 4 is equal to dx, isn't it? So here, if I am just taking only cos, so cos of u into dx by, dx changes to what? Du by 4. So du by 4. So this becomes 1 by 4 times integral of cos u into du. That is 1 by 4 times u is integral of cos u is sine u plus c. So what is integral for u here? Sine of 4x plus 10 plus c. So exactly this part is what I am getting here. 1 by 4 sine of 4x plus 10. It is substitution coming in between, but since we are familiar with substitution, this integration, we are directly writing the integral value. Am I clear? Okay. Let's see more questions on this kind. So we are moving on to the third exercise, 7.3. Okay. Now let's see a question to integrate integral sine cube of 2x plus 1. Now I have this sine cube as sine square 2x plus 1 into sine of 2x plus 1 into dx. Isn't this sine raised to 3x 2x plus 1? Yes. Now here sine square, I will write this as 1 minus cos square 2x plus 1. Is that fine? Into sine of 2x plus 1 into dx. Now I substitute for u is equal to cos of 2x plus 1. Okay. Now what do I get? Du is equal to, what is the derivative? Minus of sine of 2x plus 1 into 2 into dx. So I get this as du by 2 negative of is equal to sine of 2x plus 1 into dx. Now sine of 2x plus 1 into dx. I have it here. So I can write this as integral of, I have a minus du by 2, that I will be replacing it for what? For this particular expression, sine of 2x plus 1 into dx. So what do I get? 1 minus u square. 1 minus u square into minus of du by 2. That is minus of 1 by 2 into integral of 1 minus u square into du. Now what is the integral of this? That is minus 1 by 2 into u minus u cube by 3 plus c. Now I substitute for u, that is 1 by 2 times u is what? Cos of 2x plus 1 minus cos cube 2x plus 1 by 3 plus c. So this is the answer. Okay. I hope this is clear to you. Well, now let's see this. Now here I have the formula, that is this integral I can write it as cos raised to 4x into sine of, cos of 4x, cos 4x into sine 3x. I multiply it by 2, I divide it by 2 and I have the formula as 2 cos x sine y. What is 2 cos x sine y? You remember? It is there in their textbook. Okay, I'll write it here. That is sine of x plus y minus sine of, yes, what do you have it there? Sine of x plus y minus sine of x minus y. Okay, so I applied here 1 by 2 into, what is it? Of course the integral sign is there. Sine of x plus y is what? Sine of 7x minus sine of x into dx. Now this is equal to 1 by 2 into, I am just integrating this. What is the integral of sine of 7x? That is minus of cos 7x by 7 minus sine x, that is minus of cos x. So this becomes plus c. So I may write this as minus of cos 7x by 14 plus cos x by 2 plus c. So this is how I integrate it. I hope it is clear. Now let's continue the questions. Here I am going to integrate integral 1 minus cos x by 1 plus cos x. Now I recall, what is 1 minus cos x? It is 2 sine square x by 2, half angle formula. Again 1 plus cos x, it is 2 cos square x by 2. So applying it over there, I get this as 2 sine square x by 2 by 2 cos square x by 2 into dx. Now 2 and 2 cancels. What do I get? Integral of tan square x by 2 into dx. Now how do we integrate tan square x by 2? I hope you remember. I'll write this as sec square x by 2 minus 1 into dx. Now integral of sec squared x by 2 is what? Tan x by 2 by 1 by 2, because 1 by 2 is the constant there, minus x plus c. If you want, you can write this as 2 tan x by 2 minus x plus c. Am I clear? Yes. Go through it. Now coming to the next question, I write this as integral of 1 plus cos x minus 1 by 1 plus cos x. Is there any change? I don't think so. So I can club these two and divide it with the denominator. I'll get it as 1 plus cos x by 1 plus cos x minus 1 by 1 plus cos x into dx. Now, what do you get here? Integral of 1 into dx. Okay, I am splitting the integral. 1 into dx minus integral of 1 by 1 plus cos x into dx. Now, this part I know how to integrate it. How do I integrate 1 by 1 plus cos x? I will write 1 plus cos x as what? 2 cos squared x by 2. So, I'll write this as 1 into dx. Integration together at the end only. No half part integration. Minus integral of 1 by 2 cos square x by 2 into dx. Now, that is integral of dx minus 1 by 2 is common. Integral of 1 by cos squared x by 2 is what? Sec square x by 2 into dx. Now, integrate it. That is x minus 1 by 2 into integral of sec squared x by 2 is tan x by 2 by 1 by 2 plus c. That is x minus 1 by 2 into 2 into tan x by 2 plus c. 2 and 2 cancels and you get the answer as x minus tan x by 2 plus c. Am I clear? Okay. Now coming to this part, integral of Sine Cube X into Cos Cube X. Now either I can take u is equal to Sine X or I can take u is equal to Cos X. Whichever way you want you can take. So I have taken u is equal to Cos X. So du becomes what? Minus of Sine X dx. So I can write minus du is equal to Sine X dx. Okay. Now this is equal to, this is sine cube, isn't it? One of the I'll write the sine cube as sine squared x into, I have a cos cube x here. Then I will write a sine x into dx. Now this sine x and sine squared x, won't it give you sine cube x? Yes. Now why did I write it like that is because this sine x dx can be now replaced with du. Now here u is equal to cos x. Isn't it? So this sine square x, now I will write this sine squared x as 1 minus cos square x into cos cube x into sine x dx. Now you see this cos square I can replace it with what? U square, right? Into u cube into minus of du. I take that minus out. So what do I get? Minus of integral of u cube minus u raised to the power of 5 into d. Am I clear? Yes. Now everything changed into u. That is minus of u raised to the power of 4 by 4 minus, this minus taken inside, plus u raised to the power of 6 by 6 plus c. That gives me u is what? Cos x. Cos x raised to the power of 6 by 6 minus cos raised to the power of 4x. Cos 4x, cos raised to 4x or cos 4x square. 4x the square also I can write. I'll write it like this. No more confusion. So that it is cos x raised to the power of 6 by 6 minus cos x raised to the power of 4 by 4 plus c. Clear? Okay, now we are going to integrate integral of sine raised to 4x dx. Now this is same as integral of sine square x the whole square into dx. Now I know that sine squared x can be written as 1 plus cos 2x by 2, correct? As well as cos squared x, how will I write? 1 minus, sorry, this is 1 minus. This is 1 plus cos 2x by 2. Okay, so keep in mind these two formulas. That is sine squared x is equal to 1 minus cos 2x by 2 and cos squared x is equal to 1 plus cos 2x by 2. So, I can write this as 1 minus cos 2x by 2 the whole square into dx. Okay, so this is 1 by 4 times integral of 1 minus cos 2x the whole square into dx. When I expand it using a minus b the whole square, what will I get? 1 by 4 times 1 minus 2 cos 2x plus cos square 2x into dx. Here I haven't integrated it. That is 1 by 4 times integral of 1 minus 2 cos 2x plus, what is cos square x? That is 1 plus cos 2x by 2. So what is cos square 2x? 1 plus cos 4x by 2, correct, plus into dx. So this is equal to, I am going to integrate now, 1 by 4 times integral of x minus 2 sine 2x, right? 2 cos 2x integral is 2 into cos 2x is sine 2x by 2, correct? Plus 1 by 2 is common out into x plus sine 4x by 4, correct, into, this is integration over, so this is brackets plus c. If you want, you can take this 1 by 4 inside, that gives me x by 4, 2 and 2 cancels, minus sine 2x by 4 plus x by 2, x by 4, because not 4 actually, it is 8 is going to be, 4 into 2 is 8x plus 4 into 2, 8 fours 32, sine 4x by 32 plus c. So this is going to be the integral value. If you want, you can take that 1 by 32 common outside and you can simplify this. Otherwise, this is also fine. Am I clear? Let's see the next question. Okay. Now, here in the denominator, I have 1 plus sine 2x. This is a board question, year before last. Okay. So now listen. Here, I need to consider sine x plus cos x the whole square. What is sine x plus cos x the whole square? We will be seeing this quite a number of times when we go for definite integral. This is indefinite integral. We are not finding the value of c. When we find the value of c and substitute under particular given conditions, it is called as definite integrals. Okay. We will come to definite integrals in the later sessions, but now this is indefinite integrals. Okay. So, what is the expansion of this? That is sine squared x plus cos square x plus 2 sine x cos x. Isn't it or not? Now, this 2 gives you what? 1 plus 2 sine x cos x. Can I write it as sine 2x? Yes or no? Yes. So, here in this question, I will now rewrite this as the numerator remains the same. Denominator, I will replace 1 plus sine 2x with sine x plus cos x the whole square into dx. Now you might have come to know, substitute for u is equal to sine x plus cos x. What is the derivative? du is equal to derivative of sine x cos x. Derivative of cos x is minus of sine x into dx. Now see, this is exactly the numerator. Isn't it or not? So, you can directly write this as 1 by u square into du. That is u raised to the power of minus 2 plus 1 by minus 2 plus 1 plus c. That is minus of u raised to the power of minus 1 plus c. What is that? Minus of 1 by sine x plus cos x the whole, no squares, plus c. So, minus of 1 by sine x plus cos x plus c. So, that is going to be the answer. Okay. Now, let's see another question. Here you have integral of cos 2x plus 2 sine squared x dx by cos squared x. Now, when I have a cos 2x, I can think about cos squared x minus sine squared x. The formula is there? No. Cos 2x is equal to what? Cos square x minus sine squared x. So, I will be applying this formula over here. I get this as integral of cos squared x minus sine squared x plus 2 sine square x by cos square x into dx. Now, this is equal to integral of cos squared x plus sine square x by cos squared x, because this value, when you simplify, you get it as sine square x. So, this is integral of 1 by cos square x into dx, because sine squared x plus cos squared x is what? 1. So, this is sec square x into dx. What is integral of sec squared x? Tan x plus c. Okay. This is quite simple as it is. But this is again a board question. Okay. Now, coming to the next one. 1 by sine x into cos cube x into dx. So, here I will divide and multiply the denominator. We have already done one of this kind. Denominator and the Denominator I multiply with cos x, divide with cos x. So this becomes integral of 1 by tan x. Why did I do that like that? This gives me tan x into cos 4x into dx. Now this is equal to integral of sec raised to 4x by tan x into dx. Now this is equal to sec raised to 4x, I can write it as sec squared x into sec square x by tan x into dx. Now one of the sec squared x, I'll write it as 1 plus tan square x into sec square x by tan x into dx. Now I substitute for u is equal to tan x. What is du? It gives me sec square x dx. So this is equal to integral of 1 plus what? Tan x is u. So I can write u square by u. Sec squared x dx is now du. So this gives me integral of 1 by u into du plus u square by u into du. One of the u square cancels. I get it this as log u plus u square by 2 plus c. Resubstitute with u. So log of tan x plus tan square x by 2 plus c. So this is the final answer.